So let's do the integral of sine of 2x over the square root of sine squared of x plus 1. The integrand has sine x terms and sine of 2x terms, which means we have sine functions with different angles in the expression. It would be helpful if we could rewrite the entire expression with only one angle in the arguments of the trigonometric functions. We can use the double angle formula, sine of 2x equals 2 sine x cosine x, to rewrite the numerator as 2 sine x cosine x, and the denominator stays the same. So this is just 2 sine x cosine x divided by sine squared of x plus 1 under the square root as the new integrand. The great thing about rewriting the integrand in this form is that we now have a single cosine x term in the numerator, with the rest of the expression in terms of sine of x. Since the derivative of sine of x is cosine of x, this means we can do the substitution u equals sine of x, which means du equals cosine of x dx. If we substitute this into the integral, this becomes the integral of 2u over the square root of u squared plus 1 du, since we would replace the cosine x dx with du, and since u equals sine of x, 2 sine of x over the square root of sine squared of x plus 1 just becomes 2u over the square root of u squared plus 1. What we need to do now is do another substitution. We can see that the u squared plus 1 in the denominator has a derivative of 2u, which is exactly what we have in the numerator. So we can let v equal u squared plus 1, which means dv equals 2u du, and if we substitute this back into the integral, this becomes the integral of 1 over the square root of v dv, since we replace the 2u du with dv, and the 1 over square root of u squared plus 1 just becomes 1 over the square root of v. The integral of 1 over the square root of v is just 2 times the square root of v by the reverse power rule, and we have to add the constant of integration c. Since we let v equal u squared plus 1, if we substitute u squared plus 1 back in for the v, we get 2 times the square root of u squared plus 1 plus c. Since we also set u equals sine of x, if we substitute that back in for the u, we get 2 times the square root of sine squared of x plus 1 plus c. So the integral of sine of 2x over the square root of sine squared of x plus 1 is 2 times the square root of sine squared of x plus 1 plus c.